Have you ever wondered how many dimensions the universe actually has? It's a curious question that has intrigued thinkers for centuries. We live in a world of three dimensions: length, width, and height. But what if these are just the tip of the cosmic iceberg? Imagine a universe where the fabric of space-time extends beyond our comprehension. Unseen dimensions that could be hiding in plain sight, just waiting to be discovered. What if I told you that our universe could have more dimensions than we can even fathom? Before we dive deeper, we must understand what a dimension is. Imagine a one-dimensional world. It's a world that's as thin as a thread, extending endlessly in only two directions, forward and backward. This is a world without height, without depth, only length. You could think of it like a highway that stretches endlessly into the horizon without any exits or detours. But what if we add another dimension? What if we could not only move forward and backward, but also left and right? This would give us a two-dimensional world, a flat plane extending endlessly, not just in two, but in four directions. You could imagine it like a vast sheet of paper, where you can move in any direction along its surface. Now, let's go a step further. What if we could move not just forward, backward, left and right, but also up and down? That's right, we're now in a three-dimensional world. This is the world as we know it, the world we live in. It's a world of depth, of volume, a world where we can move in any direction in space. But wait, there's more. What if there were more dimensions than just these three? What if there were dimensions beyond length, width, and height? This is where things start to get really interesting. The idea of higher dimensions is a key concept in modern physics. In fact, some theories suggest that there may be as many as 10 or even 26 dimensions. These aren't dimensions we can see or touch or move in, but they're dimensions that exist nonetheless. Dimensions that could help us explain some of the deepest mysteries of the universe. So in essence, a dimension is a direction in which we can move that is independent from all other directions. In the world we perceive, we're familiar with three such directions, but who knows? Perhaps there are more directions, more dimensions, waiting to be discovered. Perhaps there's a whole unseen universe out there, a universe of dimensions beyond our wildest imagination. Now imagine a universe where there are more than just three dimensions. Sounds mind-boggling, doesn't it? But this is exactly the world that physicists are exploring through the lens of string theory. String theory, to put it simply, is the idea that the fundamental particles we observe are not zero-dimensional points but one-dimensional strings. You see, in our everyday life we experience three dimensions: length, width, and height. Add time to the mix and we get a four-dimensional reality. But string theory suggests that there might be more dimensions that we just can't see. In the realm of string theory, the universe isn't a four-dimensional entity. Instead, it balloons to a staggering 11 dimensions. That's right, 11. This includes the three spatial dimensions and time that we're familiar with, plus 7 additional dimensions compacted so tightly that we can't perceive them. But why would we need these extra dimensions? Well, they're a crucial part of the mathematical consistency of string theory. Without these additional dimensions, the equations just don't work out. And if there's one thing physicists can't stand, it's a universe that doesn't make mathematical sense. The concept of higher dimensions opens up a whole new world of possibilities. It suggests a universe that is far more complex and fascinating than we could ever imagine. It propels us to question our understanding of space and time, to challenge the very fabric of our perceived reality. And it leaves us with a tantalizing question. If these dimensions exist, what could be hiding within them? Are there parallel universes, unseen forces, or even other forms of life lurking in these hidden dimensions? The truth is, we don't know. The mathematics points us in the direction of higher dimensions, but the physical evidence is yet to be found. It's like trying to hear a symphony in a world where only a single note can be heard. What if we are just a small part of a multidimensional universe, and we are only experiencing a fraction of its true complexity? You might be wondering, where is the evidence for all these extra dimensions? Well, the evidence, as they say, is in the pudding, or in this case, the behavior of gravity and quantum particles. Physicists have long puzzled over the peculiarities of quantum mechanics, the branch of physics that deals with the smallest particles in the universe. They've noticed that these particles often behave in ways that don't fit our three-dimensional understanding of the world. For instance, particles can be in two places at once or instantly affect each other over vast distances, phenomena that are inexplicable in a three-dimensional universe. Could these quirks be evidence of higher dimensions? Then there's gravity, the force that keeps our feet on the ground, yet is surprisingly weak compared to the other fundamental forces of nature. This weakness has baffled scientists for centuries. One intriguing explanation suggests that gravity might be seeping into other dimensions. In a higher dimensional universe, gravity would spread out over the extra dimensions, diluting its strength in our three-dimensional world. But it's not just theoretical physics providing clues. Cutting-edge experiments are also hunting for signs of extra dimensions. At places like the Large Hadron Collider, scientists are smashing particles together at close to the speed of light. They're looking for signs of gravitons, hypothetical particles that mediate the force of gravity, disappearing into extra dimensions. If these gravitons are found, it would be a game-changer, providing concrete evidence of dimensions beyond our perception. However, it's important to note that all of this evidence is indirect. While it hints at the existence of higher dimensions, it doesn't conclusively prove their existence. Much like Sherlock Holmes piecing together clues to solve a mystery, physicists are gathering evidence, forming hypotheses, and testing theories in their quest to understand the true nature of our universe. While the evidence might not be conclusive, it certainly suggests that our universe is far more complex than it appears. So, the next time you gaze at the stars, remember, there could be more to the universe than meets the eye. So, what would it mean if our universe really does have more than three dimensions? Well, in the simplest terms, it would be a game changer. It would force us to rethink everything we thought we knew about the universe and our place within it. Three dimensions, as we know them, offer a relatively simplistic view of the universe. However, if we add more to the mix, the complexity of the universe increases exponentially. Let's start with the possibility of parallel universes. The concept of a multiverse isn't new. However, the existence of higher dimensions could provide the framework needed to support this theory. In other words, each dimension could potentially house its own universe, existing simultaneously alongside ours. Imagine the possibilities. Entire universes existing in the same place at the same time but in different dimensions. It's a concept that challenges our understanding of reality, isn't it? Now, let's talk about space-time. Our current understanding of space-time is based on a four-dimensional model. 3 dimensions of space and 1 of time. But consider the implications of a universe with more than 3 spatial dimensions. It could mean that time isn't the only dimension that influences how we perceive the universe. Other dimensions could also play a role, potentially leading to a completely different understanding of space-time. Further, higher dimensions could also offer new possibilities for space exploration. We've long dreamed of faster-than-light travel, and while it remains a distant dream in our 3-dimensional universe, higher dimensions could potentially make it a reality. Imagine being able to traverse vast distances in the blink of an eye, or even exist in multiple places at once. The implications are staggering, and while we're still a long way from understanding or accessing these higher dimensions, the possibilities they offer are truly exciting. So, to wrap it up, if our universe does indeed have more than 3 dimensions, it would fundamentally change our understanding of the universe and open up new possibilities for exploration and discovery. We have journeyed through the concept of dimensions, from the simple to the complex. We started by asking the curious question, what is a dimension? And found it's not just about length, width, and height. We uncovered that dimensions are fundamental building blocks of reality, defining how we perceive and interact with the world around us. We then dove into the deep end, exploring the possibilities of higher dimensions and their relationship with string theory. We discovered that these unseen dimensions could be compactified, coiled up in the fabric of space-time itself. We examined the evidence, from the peculiar behavior of subatomic particles to the large-scale structure of the universe. We saw how these clues pointed to the existence of higher dimensions, providing a new perspective on the mysteries of physics. Next, we discussed the implications of dimension theory. We pondered about the possibilities that lie beyond our understanding, such as parallel universes, quantum entanglement, and the very nature of reality itself. And now, here we are, at the end of our journey, but it's far from over. As we push the boundaries of knowledge, we continue to explore, to question, to wonder. We continue to delve into the unseen universe, to unravel its secrets, and to understand our place within it. The journey into the unseen universe is only beginning. Who knows what we will discover?